In this video, we are looking at automatic data validation in FastAPI. Every API receives data it cannot fully trust, and the way FastAPI handles that, using Python type hints and Pydantic, is one of the things that makes it genuinely different from most other frameworks. By the end, you will know exactly how it works and when to lean on it. Before FastAPI, handling a POST request meant writing a wall of defensive code. Pull the JSON body, check that each key exists, verify the value is the right type, coerce strings to integers, and then craft a useful error response if anything was wrong. Every endpoint repeated that same tedious pattern, and skipping even one check was a silent bug waiting to corrupt your database or crash your service. Think of FastAPI's validation layer as a bouncer standing at the door of your endpoint function. Every incoming request has to show valid ID, the right fields, the right types, values inside the allowed range. If anything is off, the bouncer turns the request away immediately and tells the caller exactly what was wrong. Your actual business logic, the staff inside, never even sees bad data. The system has four named pieces. First, a Pydantic BaseModel, that is a Python class where each attribute carries a type annotation, and that annotation is the contract for what valid data looks like. Second, field, a function from Pydantic that lets you attach constraints like minimum value or maximum string length directly to a field. Third, validators, which are methods decorated with @field validator that run arbitrary Python logic on a value. When validation fails, FastAPI automatically returns HTTP 422 unprocessable entity with a structured JSON body describing every problem. At the top, we import FastAPI, BaseModel, field and field validator from their respective packages. The product class extends BaseModel, making it a Pydantic model. The name field uses field, with min length 1 and max length 100. Those are hard constraints. The price field uses GT0, meaning strictly greater than 0, so a price of 0 is rejected. The stock field defaults to 0 and uses GE0, meaning 0 or more. The field validator method decorated with @field validator for name runs after the type check. It strips white space and raises a value error if the result is empty, which Pydantic converts into a clean validation error. Finally, the path operation createProduct declares product as type product. FastAPI reads the request body, feeds it to Pydantic, and your function only executes if every rule passes. When a request arrives, FastAPI extracts the raw JSON and hands it to Pydantic. Pydantic first tries to coerce each value to the declared type, so the string 3 becomes the integer 3 automatically. Then it applies field constraints, range checks, length limits, and rejects patterns. Then your custom validators run. If anything fails at any step, FastAPI short circuits and returns a 422 response, whose body is a JSON list, where each item names the field, shows the bad value, and explains the rule that was broken. If everything passes, your function receives a fully typed, fully clean Python object, no parsing code required from you. Reach for automatic validation whenever you accept structured JSON and want deterministic, well-documented rules enforced at the boundary of your API. That is almost always. The main time to pause is when a validation rule cannot be answered from the data alone. For example, checking whether a username is unique requires a database query, and that belongs in a FastAPI dependency or your service layer, not inside a Pydantic validator. Also, resist the temptation to embed heavy business logic inside validators. Keep them focused on shape and format. To summarize, declare a Pydantic model, type hint your parameter with it, and FastAPI handles all parsing, coercion, and error responses for you. Use field to express constraints like minimum value or maximum length, and use field validator when you need a custom rule. Remember the boundary. Validators are for checking the shape of data, not for querying databases or running business logic. Those belong one layer deeper in your application.